So today we're going to continue looking at the law of signs, and we're going to look at something called the ambiguous case. The ambiguous case of the law of signs only happens when the information given is two sides and a non-included angle. So if you were looking at a triangle, try that again. There you go. So if you're looking at a triangle, maybe look something like this. Okay, we would be getting maybe this side, call that side A, and maybe we get this side, which is side B. This would be an included angle between side A and side B. But what this is saying is that we get one of these angles, one that's not included. So maybe it's this one, or maybe it's this one. Okay, and that's the only time that the ambiguous case can possibly be an issue. Okay, any other combination of things where you can use law of signs, there's one possibility, it works, you go with it. But when we have this SSA, which is side angle, two sides and a non-included angle, that's when we have the possibility of this ambiguous case. So in the SSA case, different scenarios are possible that affect the number of triangles that could exist with the given measurements. So they're going to give you 3 of the 6 measurements. And in the ambiguous case, there are different possibilities as to how many triangles can actually exist with those given measurements. Now, before we continue with this lesson is going to be a little bit more activity-oriented. And as we go through the lesson, you may want to have some colored pencils or pens that you can use to differentiate the different possibilities in your notes. So if you don't have any right now, but you can find some real quick, go ahead and pause the video, go find something that's in different colors, or maybe like a red pen, a blue pen, a pencil, just things that are different so you can differentiate what you're going to be doing and what you're going to be seeing. All right, so if you look in your notes page on your booklet, you'll see that there is a ray there on your paper. And what I want you to do is to take a protractor and actually measure an acute angle. Now, if you don't have a protractor, then just draw something that you know is acute. Okay, and I want you to draw the ray that gives you the other side of your acute angle as 10 centimeters long. Okay, so you might get something that looks like this. So this is the ray that's on your paper, this black ray right here. I've chosen 40 degrees for my angle, and I'm drawing my other side of my angle here, and this line is going to be 10 centimeters long. That's what we want. Okay, now with each of these steps here, if you need to pause the video for a second to complete the step, go ahead and do that, because it's important that you're actually doing these steps to see what's going to happen and what the different possibilities are. Okay, so now we're going to do some labeling. So we're going to label the vertex as angle A, and the ray that you drew is going to be side B. And then we're going to draw a segment from the free endpoint of side B perpendicular to the ray on the paper. Draw this as a dotted line. That dotted line is going to represent the height of whatever triangle we create, and so we're going to label that H. So this is what it should look like. Here's our A that we're labeling for the vertex of the angle. The 10 centimeters here is now our side B. And then from the free endpoint perpendicular down to our black ray that was given to us, That's the dotted line that we're supposed to draw in, and we're labeling that H because it represents the height. Okay, so the next thing I want you to do is to figure out what the measure of H is without measuring it. So if you actually used a protractor to measure your angle, then I want you to try to figure out what H is with your particular angle. If you did not have a protractor, then go ahead and figure out what it would be using the 40-degree angle that I used. But take a minute and see if you can figure out what H would be for your triangle. Okay, so the key to this is to realize that if I am drawing H perpendicular to the black ray that was on my paper, then that makes my triangle with H as a side a right triangle. So I can use our sine of theta as being opposite over hypotenuse because I'm in a right triangle. So that means the sine of A is going to be equal to the H over the B. And in order to get H by itself, I simply multiply both sides by B. And so that gives me the equation that H equals B times the sine of A. So now I can actually put in the measurements. We have 10 for B. That should be the same for everyone. I used 40 degrees as my angle. You may have something slightly different there. And so in my case, I have a 6.42 as the value for H. Okay? All right, so now imagine a line segment that is shorter than what H is. And then imagine your line segment's endpoint is attached to the free endpoint of side B. Since this new segment is opposite of angle A, we would call this side A. Now, how many triangles can you draw using this length for side A? Go ahead and pause the video for a moment if you need to. Draw in whatever triangles you think you can create, and then come back for us to continue. All right, so if you're choosing a segment that is shorter than H, and you think about all of the different possibilities of where that segment can go, you'll notice that this segment is never going to reach the other side. So when it comes to drawing a triangle, it's not possible. Given this side is 10, this angle is a 40, and this side, this green side, as a side that is shorter than whatever your H value is, it is not possible to create a triangle with those measurements. So this is one scenario that can happen in the ambiguous case. If our A side is shorter than the H, that would be the value from here all the way down to here, then we know that we cannot get a triangle from those measurements. Okay? All right, so now let's think of another possibility. Imagine a line segment that is equal to H. And again, imagine your line segment's endpoint is attached to the free endpoint of side B. How many triangles can you draw using this length for side A? Okay, and again, pause for a second, draw in what you think, come back and we'll continue. So if my side now, my side A is actually the same length as H, I know I can create this triangle. But can I create any other triangle? Well, you'll notice if I take that same length and move it in different positions, there is no other triangle that can be created. So if my A side is actually equal to H, then there's just one possible triangle. And it's actually a right triangle, so you could go about solving our triangle using right triangle methods instead of using the law of sines if you wanted to. Okay, so that's another possibility. When the A is actually equal to our H, there's only one possible triangle that can be drawn with those measurements, and that's what we would solve. Okay, another possibility. Imagine a segment that is longer than side B. And imagine your line segment's endpoint is attached to the free endpoint of side B. How many triangles can you draw using this length for side A? You might have to imagine that that black ray that was given to you on your paper extends farther than what is actually drawn. Okay? Go ahead and draw what you think that's going to look like. How many different triangles can you get with that measurement? And again, try to use a different color if you can. All right, so if I choose something that's longer than side B, and you notice here I just went a little bit longer so things will fit on my screen. But if we move this side around to different possibilities, notice that about the only place I can create a triangle is way out here. Anything else less than that came down this way overshot to this other side and did not create a triangle. And so it's only out here that I can create this triangle, and so again there's only one possibility when my A side is actually longer than my B side. Okay? All right, try this one. Imagine a line segment that is longer than H but shorter than B. Imagine your line segment's endpoint is attached to the free endpoint of side B. How many triangles can you draw now? Again, try to use a different color for this if you can. All right, so we're going to now choose a segment that's longer than H. So you can see here how it's longer than H, but you can see here how that same segment is shorter than B. Okay, so if we do that, we get one triangle here. Okay, this side meets up with this side right here, creates an obtuse angle right here, another acute angle here, and this is one possible triangle. But is it the only possible triangle? If we keep trying more positions, we find there's a second option out here. And in this option, this angle is created as an acute angle. This angle could be acute, could be obtuse, not really sure at this point. But the difference is that this angle in this possible triangle is acute, whereas that inside angle when it was over here was obtuse. And that's going to be really important in our next lesson to remember that. So when we have this scenario where our A side is longer than H but shorter than B, there are two different triangles that could be created. And if that's the case, then when we do the solving of a triangle, we have to solve both possibilities because we don't know which one is actually being considered based on the measurements we're given. Okay? Now, draw a different side B. So that first side that you drew at the beginning of this activity, draw it again, but make it so that angle A is an obtuse angle. Now imagine a line segment that is shorter than B. Imagine attaching your line segment to the endpoint, just as we've done before. How many triangles can you draw with this length for side A, now that our angle A is obtuse? Draw whatever you can with a different color. Well, again, if we pick something that's shorter than our B side, there's no way that that side is going to reach our black side over here to create a triangle. And so here's another case where we're not going to get any triangles with these measurements. Okay, so you should not have drawn anything for this scenario. But what about if we choose a line segment that is longer than side B? Imagine attaching that segment to the endpoint. How many triangles could you draw now? So if we're choosing a line segment that is longer than B, then as I move it around, I find that there's only one possible triangle that can be drawn. There's nothing else that's going to work and connect. So when our angle is obtuse, it's a little easier because there's only two different possibilities. Either we get no triangles or we get one triangle. When our angle is acute, there's more possibilities, and so we have to think through those possibilities a little bit more. So let's summarize here what we've just gone through, and this is on the back side of your note sheet if you want to fill this in. So if we have a situation where we know this side length and this side length, and we know this angle. So we know that the other side has to be out here somewhere. We just don't know how long it is. Here's our h to represent that distance. So in this case, when a is less than h, then we know we have no triangles possible. If the a is actually equal to h, then we've created one possible triangle, and it's actually a right triangle. If our a value is actually bigger than our b value, then again, we're only creating one possible triangle when it comes out here to the side. But if our a value is something that is bigger than h and less than b, that's that strange situation where we get two possible triangles. And all four of those are in the situation where our a angle is acute. So you notice all four of these are under that heading of A is acute. If, on the other hand, A is obtuse, then we really only have to worry about two things. Is A less than or equal to B, or is our A greater than B? If A is less than or equal to B, then there's no triangle. But if A is greater than B, then there's going to be one triangle that we can solve. Okay, so in order to keep all of this straight, because this is a little bit weird and a little bit crazy, what I want you to do for your quote-unquote homework for tonight is to make a foldable. A foldable is just kind of a paper pamphlet that you can make by folding pages in a certain way and then filling in parts of those pages to help organize information. So in your book, you have directions on how to make this foldable. That is what I want you to do for your homework, is just make the foldable, following the directions in the book, and have it ready for our next lesson, which will be next class. There is no other homework for today besides just making the foldable. But you really do want to have this ready to go before you watch the next video for the next lesson, which you should be doing next class. Okay, so that's it for today. No practice in the book, just make your foldable and be ready for next class. We'll see you then.